Class limits, class width. Now the lower class limit is the smallest value within the class. Upper class limit is the highest value within the class. Class width is the difference between consecutive lower class limits or between consecutive upper class limits. So let's understand these definitions through an example. Suppose the male athletes at a university have the following weights. So now this info can be summarized as follows. So we see that in 160 to 169, we have 164 and 169. And we also have 165. So 1, 2, and 3 entries fall in the region 160 to 169. And then between 170 and 179, we have only one entry, that is 172. So that's one here. And between 180 and 189, we see 180 and 184, so two. And between 190 and 199, we have 192 and 196, also two. So these counts are the frequencies or the number of athletes. So here we have four classes, and if you are asked the limits of the second class, so the lower limit of the second class is 170, and the upper limit of the second class is 179. And if you're asked the frequency of any class, so for example, the frequency of the second class, this is the second class, the frequency of second class is actually 1. Frequency of second class is not 15, but 1. So, class width. Now, in the definition, we said class width is the difference between consecutive lower class limits or between consecutive upper class limits. So if you want to use consecutive lower class limits, so 160 is a lower limit of this class, and the next class has a lower limit of 170. So we see the difference between the two. 170 minus 160, that's 10. And you can basically take any two consecutive lower limits or two consecutive upper limits. So for example, you could also take like 189 and 199. The difference here is also 10. And one question is, why shouldn't classes overlap in a frequency table? So as you see here, the classes don't overlap. So we go 160 to 169, and the next one starts 170 to 179. So we don't say 160 to 170 here and 170 to 179. Because if we were to say that, so then you can see, for example, from this data, so let's say the second class was 170 to 180, and this was 180 to 189. So that would be an overlap. The 180 is an overlap between the second and the third. And then if that were the case, then you wouldn't know where to place 180. So the reason why classes shouldn't overlap is so that there is no confusion as to which class an observation belongs.